Assalamualaikum warahmatullahi wabarakatuh. So, today we will continue our third lecture on the load calculation analysis. So, this is the continuous from the previous example, which is the exercise one, which is previously we do the five-story building, and then we find the cooling load of an office using the cooling load form. So now we will continue to the next exercise. So like previous one, please prepare your cooling load form with you, and then the formula and appendix table, which is in page 8, 9, 10 and 11. So but somehow I've been transferred it into this PowerPoint for easy for you to refer one. And then okay, so now we'll be doing the cooling load for the office also, uh, but this is for the university computer room. So basically this is the office that are located in the computer room. All right, so the first one, please read the specification of the construction, which is this one is the building for three-story building. Then the outside wall is medium construction and window glass is normal 6 millimeter thickness. The floor concrete linoleum, ceiling only concrete, and then we have the lighting, which is the fluorescent light. And then the person is now is 20%. The area is standard temperature area, and they have additional electric apparatus, which is the LCD, which is 240 watt of heat, and then the computer for that particular office or classroom is 21 times 4 527 watt. So basically this is not an office, but it is a classroom, uh, laboratory. Laboratory. All right. Okay. So um, let's go look into the plan, which is this is the plan. So the first one you have to check is the orientation of north, which is here is the orientation of north in this side. So this is the north side, and then this is the south side. So you can easy for us, maybe we can put this area is north south. So this side will be west, and then this side will be the east. So this wall will be the northwest side. So this is northwest, and then this will be the this one will be the north south west east. So this is the southwest, and then we have another one here will be the northeast, and then here one more is this is south, this is east, so this will be the southeast. All right, so so which one is facing to the outdoor? So since this is the second floor of the building, three-story building, so this is next room and then next room. So this will be the partition. So on the northwest side, we have the door here. So of course this side will be the corridor or inside of the building, so the people cannot enter from the outside of the building, right? So this one of course will be the partition, or we can call it as a wall that are not facing to the outdoor. So we have only one wall that are facing to the outdoor here. All right, so as usual you have to put the name. For example, Ame here, address, UTM here. Name of the room, okay, the first one we have changed it to the laboratory, right? So the floor is the university. Name of the person in charge, so you can put it, may also the room area. How much is the room of the building is, as you can see here, the 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 size, the dimension is 7.93, 7.93 times 7.32 here. So it is 58.05 meter square. So here meter square. So what is the room volume here? You have to look into the ceiling height. So it is given here, the ceiling height is 3 meter. So from the room area is 58.05. You have to multiply with 3. So you get the room volume is 174 meter cube here. So let's start with the wall face to the outdoor. The first one, we put, there's only one wall that faces to the outdoor, which is the southeast one. Southeast equal to 7.93 times, the area of this wall is 7.93 times ceiling height is 3 meter times 3, but you have to minus with the window here. We have two window here, which is 1.48 times 1.48, and then we have to multiply with 2 since it is have um, two window here. So now we have only one wall face to the outdoor. So is it we have roof here? So I don't think so, because it is in second floor. So second floor is the middle one, so it is only have ceiling with the concrete. So now let's go to the window glass. Window glass is same as previous one. It is facing to the outdoor one. It is southeast area. Southeast is equal equal to the size of the window is 1.48 times 1.48 meter times 2. We have two window glass here. Is there any other wall that facing to window that facing to the outdoor? No, we have only one window glass here. And then how much the partition we have here? The partition is, we have 1, 2, 3. All of the wall or window or glass that are not facing to the outdoor, we have to consider it as a partition. So now we have one wall here, as it is located in southwest. Southwest is equal to 7.32 times 3 ceiling height. Here 7.32. So the dimension is here 7.32 times ceiling height is 3 meter. So same goes to northeast. Northeast is equal to 7.32 times 3 meter ceiling height. And then we have one more here. It is the wall here, or we consider it's a partition in the northwest. So it is northwest is equal to all of the wall here is 7.93 times 3 ceiling height, and then we have to minus with what we have here is door, two doors here. We have to minus with the 2.09 times 1.24 meter, and then we have to multiply with 2 since it is have two door there. Alright, next one, ceiling. Do we have the ceiling here? Yes, of course. Ceiling area will be 7.93 times 7.32. So 7.93 times 7.32 meter, and then the floor will be same 7.93 times 7.32 meter here. So now we can move on to the area. How much of the area here? before we begin with the coefficient, we can go for the area here. The area for the southeast wall is, you have to use calculator, easy for us to minus that one. 7.93 times 3, and then you have to minus with the 1.48, multiply with the 1.48 times 2. So I hope you guys get the same answer with me, which is 19.4 meter square. And then for the window glass that we have here is 1.48 times 1.48 times 2 is 4.38, 4.38, but we can goes into 4.4 here. All right, so the partition that we have here is southwest, 7.32 times 3, 7.32 times 3, so we get about 21.96. Or we can put here 22 meters square. We just round the number, and then the northeast also same, 22 meters square. And then the northwest wall is 7.93 times 7.93 times 3, and then we have to minus with the door, which is 2.09 times 1.24, multiply with 2, so we have about 18.6 meters square for the partition of the uh, northwest. Yeah, I forgot to put here, this one is for the wall, but we have here is door, right? Door here is equal to 2.09 times 1.24 times 2. So we should put here 2.09 times 1.24 times 2. Here is 5.12, or we can just put it 5.2 meter square here. And then the ceiling, how much is the ceiling area? 7.93 times 7.32 is 58, and then the floor is also same, 58 here. So how about our room volume? We have calculated it previously, it is 174 meter cube here. Just put 174 meter cube here. The person, looking at the specification of the building, how much of the person is 20% here. Number, just put 20% here. And then the lighting is fluorescent light, so fluorescent light is 40 times 12 watt. 40 watt times 12 is 480 kilowatt, but we have to put here 4.8 kilowatt here. Is there any electrical apparatus? Yes, it is LCD, one pieces 240 watt, and then we have the computer for 21 pieces. So we have to calculate it. You can put here maybe 21 times 5 to 7, and then we have to add with 240 watt. So here will be the 21 times 5 to 7 is 11,067, plus the LCD watt is 240, it is 11,307. So in kilowatt is 11.3 kilowatt here. Is there any gas or LPG or LNG? No. So now we go to the coefficient of B. Let's look into the coefficient of B, the window glass. Okay, the first one is the wall that are facing to the outdoor, so we go into wall face to the outdoor. It is on the southeast. Southeast, it is a medium construction, right? Medium construction here, and then it is southeast here. This is the value of the coefficient B, so we have to put here 38. And then the window glass, we move into the window glass here. It doesn't have any roof here, right? So that's why we just skip it, and then we go to the window glass. let's look into the specification of the building. The window glass is normal 6 mm thickness with blind here. So the coefficient of B here is win normal glass plate 6 mm thickness, and then it is located in the southeast here. It is 390. So don't forget to put into the coefficient of blind here, since it has blind there, so vegetation blind we have to put here it is 0.7. Alright, next one, partition. So shielding. Okay, right. Yeah, here it is partition of the room. So since it is a wall, so we just take the others coefficient of B. So this one will be 8. Here will be 8. This one will be the wall also 8. Here is door. Door we have to choose the coefficient of B for glass or wooden plate. It is 13. So next one, the ceiling and floor. So let's look into the coefficient again. The specification is ceiling, floor concrete linoleum, ceiling is only concrete. So now yeah, here the ceiling is only concrete, it is 10. Here it is 10, and then the floor is linoleum, it is 7. Alright, so the invention of outdoor air. Look into the specification. It is a standard temperature area. Since already stated, it is a standard temperature area. Uh, so now standard temperature area here, we can choose it is 8 here, the coefficient of B. So the person we have already have the number of person here. Uh, let's look into the person here. Number area correction is 1 here. Alright, okay. Alright, uh, let's confirm the previous one is the empty one here. Wait a minute. Alright, the room. Alright, so the coefficient here we have to put, this is a laboratory. We can either choose office working or sitting on the chair. I hope since it is a computer lab, so we take the office working, since I believe that it is proper we select the office working, since it's working with a computer, right? It is better we have calculate the estimation of load is much more higher compared to the lower one. So we just put the person here, the coefficient of B here will be the 120 for the coefficient of B here. Alright, so we have complete the B part. So now we move into the C, which is we just using the Microsoft Excel formula. It is A times B, so it is equal to A multiply B with B, which is 73. Alright, so we just drag it to know the answer here. Alright, and then moving forward to the load coefficient of B here. The coefficient of load Q is equal to F times C, right? So we get 737.2 here. Alright, and then the next one will be, it is equal to this one. multiply with C here, we can get 1102. So next one is equal to 1 multiply with the C here, same 1 multiply with C, this one, then equal to this one multiply also with the C, then this one same multiply with here. Alright, so it doesn't have any partition, another partition. So now we're moving forward to the shilling. It is equal to this one multiply with the C, which is here, this one, then the same multiply with this one is here. So this one will be this one equation times C here, and then we have here also multiply with here. Alright, so now we have the fluorescent light, right, equal to 1 multiply with the 4800 here, and then here is 1 also multiply with the here. This is the total Q that we got here. So we just equal to sum, we just do double click, and then we from here to until end, let's put enter. So this is the kilocalorie is equal to this one. This is our answer, 21,802 kilocalorie per hour for the load. And then to convert it kilocalorie to BTU per hour is equal to this side multiply with the 3.968, and then we got the answer is 86,503. So it is about we can measure it here, BTU per hour to horsepower. We want to know how the horsepower. Okay, so 1 horsepower is equal to 8,000 to 9,000 BTU. So it almost one is about 10,000. We just take, usually we take about 10,000 BTU per hour for 1 horsepower. Alright, so we just convert it. It is equal to this divide by 10,000, then we can know it is 8.6 horsepower. So we doesn't have any 8.6 horsepower of air conditioning. It might be, so we have to estimate it much more higher. So for example, we use 9 horsepower here for the air conditioning for this particular area. So 9 horsepower, it doesn't have any split unit for that much big, that high, that bigger size of 9 horsepower. So might be in the room of this room we can arrange for several air conditioning. Maybe we have to use 2 horsepower, which is equal to 4, which is about 8 horsepower here, and then we can use 1 horsepower here for one quantity, so we can get about 9 horsepower of air conditioning here. This is the second exercise for this particular for cooling load area. So please try it at home and make sure you do it familiarly, because this is quite easy question, but this you have to refer back to the refer to the coefficient of load here. So till today, so See you guys soon in the next exercise. So the next exercise will be moving to another calculation, but we are not using the cooling load form later on. So till next time, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.